Hi, so now we are going to discuss about the project. I'm going to describe what you need to do in this project. This project is titled Real-Time Audio Filtering Platform. It could be offline, but the problem statement is to make it real-time. The motivation. So as you're learning the theory of different kinds of LTI filters, it will be nice if you can implement some LTI filter for some real application. We have seen many real applications theoretically in the course. For example, audio amplification or filtering, noise filtering, or selecting certain band of frequency and just transmitting that band, etc. So, but doing this project will not only make your theoretical foundations strong, but will also give you a first-hand experience of signal processing in the wild, within the real world. So what's the overall goal for your project? To make a real-time audio filtering platform. And so you have, let's say I'm speaking to the microphone and getting the audio from the speakers, and how do you filter it in real time? It could have some delay, some lag, but your system should have a facility or a handle to design the filter. For example, the user can specify the specifications that I want this much cutoff frequency, etc., and then the filter should automatically be designed. Or else, if the user wants to specify the filter parameters, that should also be possible. You have to use your imagination how you want to make the whole thing, and maybe give some visual plots so that user can tune certain parameters, or maybe by looking at the performance, some knobs the user can turn, and then you make a demo with a few popular filters yourself. For example, take a low pass filter with a given cutoff frequency, take a band pass filter or high pass filter or a band stop filter, and give a demo with that. Now, to implement, you can use any language of your choice. You can use Python, which I prefer, but if you don't want to use Python, you can use C++ or Java, etc. And keep your codes modular for flexibility. For example, let's say I want to replace your pole 0 kind of input with, let's say, HN kind of input or LCCD coefficients. So if the codes are modular, then somebody can modify them later too. Now, implementation. How are you going to implement it? You can use port audio. This is a very popular tool for real-time audio streaming. Basically, when you're speaking, the audio goes into your microphone, and the microphone data has to be read by your program. So how do you read that microphone data in real time? So for that, port audio is used. And similarly, you will have to stream your data to your speakers. How do you do that? You basically write on the output stream, and port audio will give you very simple functions which you can use to do this audio streaming. Then if you want to use Python, then it is very simple. Port audio has bindings which are called PyAudio, and this PyAudio library you can directly use within your Python, and there are some good examples in this link. And this very simple examples, just put them in your program and the program will start working. You may have to install certain things in your machine depending on which machine you are using, Linux or Windows or Mac OS. So depending on that, you may have to install certain extra libraries or things, or drivers, etc. But I have found this is very quick to implement, very quick. And if you want to go via C++ route, then there are some examples in the tutorial which you can follow. My experience is that C++ may need some time in setting up your library. You may have to install certain other softwares and things like that, but I hope it should be manageable. Then the demo which I'm looking for is, let's say you speak into a microphone, the audio goes into your computer, gets processed using the filter, and then is played back immediately through the speakers. And you keep the speakers far from mic to avoid looping or echo, right? That is obvious. Now, there should be an option for saving the audio too instead of playing immediately. For example, you want to do offline processing. So this is optional, but main goal is online processing or real-time processing, and offline processing, if you can do, that's also good. Now, the evaluation, the deadline for the whole project will be 25th of July, which is Sunday, night 9 p.m. And then you submit a short report via GitHub. I will share the GitHub link with you soon. The TAs will do that. Now this report should be up to 2 pages long, not very long report, just up to 2 pages is enough. And use this format, it's a LaTeX format, and download the files from here. And submit your codes via GitHub. Again, the links will be shared, and write your codes in a nice document with nice documentation and commentation, etc. And give a demo on your computer. We will have it via Zoom and one-to-one evaluation. So only one person per project. It's not a shared project. It means it's not a group project, individual project only. Thank you. Thank you very much.